dear friends, welcome to yet another video of Operation Research Game Theory. So, game theory is one of the important topic in Operation Research, which is actually related to a mathematical theory, which is related to a conflict and a competition situation. So there are some types of decision making situation, especially there is a situation is called a decision making under conflict. Game theory comes under this category. So there is an activity between two persons or two teams, and every team or every person, those who are in part of game, their objective is to maximize the result. Or even if you feel that there will be a situation of loss, they have to be reduce the intensity of loss. So that's why the importance of game theory. There will be two or more parties, or there are two or more teams with their interest. So that interest is called a conflicting interest. And the conflicting interest is based on the rules of the game. So there will be parties are there, they have a conflicting interest, and their conflicting interest is undergoing based on certain rules and regulations. There will be some sort of rules and regulations will be there in case of a game theory. In case of game, it is an activity which is there will be two or more person, as we discussed in the there will be two or more persons are there, and the second one, they will be according to a set of rules and regulations will be there. So at the end of that particular one, each person or each team will receive some benefits, some gain or some advantages, or sometimes there will be some sort of satisfaction. So maybe some games will give you some sort of satisfaction, or maybe these are the positive things. You are getting some benefit, you are getting some positive outcomes, you are getting some satisfaction or the positive outcomes. At the same time, maybe there will be some sort of negative outcome. Those who are losing the game, they have to suffer the loss. So that is also the part of game. So two sides are there. There will be a winning part and there will be a losing part. So when you are playing the game, there will be a winning part and a losing part will be there. So when you are the part of the game, your objective is to you are maximizing the results. So there will be a winning situation. So this is a situation of a game problem. Let us discuss some of the characteristics of a game. So once you are there in the part of game, there will be an outcome or a result for a game. So that outcome or result is known as payoff. So payoff is the outcome of a game theory. So once you are getting the result, that is called a payoff. So we are presenting the outcome in a matrix that is called a payoff matrix. Then the second one is the finite number of possible course of action. So you have a possible course of action. You have a number of experiments. You have a number of trials. You have a number of game situations. So all these things are a finite one. A finite one. So that is a second characteristic. You can count the number of possible course of action of a game situation. And the third one is that in case of individual game or a group games or whatever it is, you can count the number of people those who are participating in that game. That is called a finite number of players. There will be a clear-cut number of players. For example, if you are watching cricket, you know what will be the number of players in each team. If for India and West Indies, they are playing the cricket game. So we know what will be the number of players in Indian team and what will be the number of players in West Indies team. Though that is called a finite number of players. Then the next one is two or more opposite parties. So there will be maybe some two parties are there and more parties are there for getting a finite final result. For example, if you are taking the example of a cricket match, maybe in case of that is World Cup cricket series, so many teams are there, so they are competing. So finally, there will be once you are reaching the semi-final or quarter-final, and finally you will be there in that final match. So two or more parties are there. You have to compete several times to different teams. So finally, those who are there in that particular position, they are the winners of that particular game. So that is called some situation there will be two parties. Some situation there will be more than two parties. So for achieving the desired set of results. So that is the next characteristics of a game. So what is a strategy? In case of a game, there will be a predetermined rules. So there are some type of rule and regulation for conducting the game. That is called the strategy. So how to do a particular game, how to do a particular cricket match. So for whatever the game, if you are playing the card game, so there will be some rule for playing the card game. If you are playing the caroms, there will be a rule for playing the caroms. If you are playing the chess, there will be a predetermined rule how that particular one has to move. So that is called the predetermined rules. So that is called strategy. So there are two types of strategies, and first one is called pure strategies and the second one is called mixed strategies. Two types of strategies are there, pure strategies and mixed strategies. Then in case of a pure strategy decision situation, always choose a particular course of action. There will be a selection of a particular course of action in case of a pure strategy game situation. But in case of mixed strategy, they are following different types of strategies in order to achieve a desired result. So there will be only one strategy. It's only a particular course of action for achieving the result in case of a pure strategy situation, but it is not like that. So they have to follow different strategies, different ways in order to achieve the final result. So it is a difference between a pure strategy and a mixed strategy. We will tell you some of the important definitions of game theory, and first one is a player. So each participant is called a player. They are the part of the game and participants are called the players. The outcome of a game is called a payoff. So we are showing the outcome as a payoff matrix. So value of the game is the maximum guaranteed gain that you are expecting from a game theory. That is called the value of the game. So what is the maximum guaranteed gain that you are expecting from a game theory situation? So that is called the maximum guaranteed gain. So I will give you what is maximin minimax principle of a game theory. So the outcome of a game, as we are seeing here, there will be a matrix. It will be presenting in a matrix form. So if you are presenting the value in a matrix form, the maximum of minimum values in the row, that is called a maximin, and minimum of maximum values in the column, that is called minimax. These are the two situations: maximum of minimum values in the row and a minimum of maximum values in the column. These are the maximin and minimax. I will give an example. Let us see in this row 5, 3 and 2. So the minimum values in the row. So second one, 1 minus 2, 0. Minus 2 is the minimum value. then 8 minus 1, 1. Minus 1 is the minimum value. So, and in case of column, 8, 3, 2, 8, 3 and 2 are the maximum values. Here, let us see maximum value in the row, that is maximum of a minimum value in the row. So, in case of rows, you have taken the minimum values. Among the minimum value, take the maximum value, that is 2. And in case of a column, you take a maximum values in the column you have selected. From the maximum value, you are selecting the minimum value. So, this is called a minimax, that is 2. So, that is why we can say that maximin is equal to minimax. That is why we can say that maximin is equal to minimax. So, if there is a point of intersection, there is a point, there will be a common value of a maximin is equal to minimax. So, that point is called a saddle point. So, saddle point is the point at which maximin is equal to minimax. So, in that case, here we see the maximin is equal to minimax. So, maximin is 2 and minimax is also 2. So, there is a value that intersection point can see it is rounded in this video. You can see the value that I have rounded, that is 2. So, that is the saddle point where the maximin and minimax intersecting. So, that value is called that rounded value, that is 2, is called the value of this particular game. So, here if a problem like this, there will be a maximin and minimax. Maximin is equal to minimax. So, such type of a problem is called a pure strategy game problem. So, in case of a pure strategy game problem, there will be maximin is equal to minimax, and in that case there will be saddle point exit. So, the value in the saddle point is called the value of the game. So, that is the nature of a pure strategy game problem. Let us see the next area, dominance principle in game theory problems. So, if you have a particular matrix that is greater than a 2 into 2 size, the principle of dominance that you can apply to reduce the size of a payoff matrix by eliminating the strategies that would never be selected. So, there will be a rule for reducing a bigger matrix to a 2 into 2 matrix. So, that is called the principle of dominance. And the first one, in case of row, all the elements less than or equal to other row, the lowest row can be eliminated. That is the first one. And another one, all the element less than or equal to other column, the highest column can be eliminated. So, these are the two rules, and first one is the lowest row and second one is the highest column. Lowest row and highest column. Let us see an example of a principle of dominance. See, there will be two players and three possible set of outcomes, and here you compare row number 2 and row number 3 of a player A, then row 3 can be eliminated. That is, row 3 is the lowest row 3 can be eliminated, then the matrix will be, so 5, 1 and 6 is eliminated in the second matrix, that is the elimination of a row process. Then compare column number 1 and 3. Column number 1 and 3, so comparing this one is column number, highest column 3 can be eliminated. See, this is the matrix of highest column 3. So, this is a way you can apply the principle of dominance. So, you are comparing the column, row number 2 and 3, lowest row 3 is eliminated. Comparing the column number 1 and 3, the highest column 3 is eliminated. So this is the way you can make the matrix into the 2 into 2 form. Then let us see how to solve a mixed strategy game. These are the two important conditions where we can go for solving a mixed strategy game. And the first one is there is no saddle point. That means there is no maximin and minimax situation. That is, maximin minimax principle cannot be applied to a particular game problem. So in that case, that is called a mixed strategy game. So in that case, we can solve that particular game problem by using three important methods. And the first one is the probability method. Second one is the graphical method. And the third one is the linear programming problem method. These are the three important methods for solving a mixed strategy game. These are the situation of the first method, probability method or mathematical method. So the method is applied in case of the three important situation, and the first one is there is no saddle point, and matrix have 2 rows and 2 columns. That means you can apply the principle of dominance, then you reduce the matrix into 2 into 2, then you can apply that mathematical method to solve the problem. And the third one is maximin is not equal to minimax. That is the third situation. If you are applying that one, maximin is not equal to minimax. So these are the three important situations you can apply mathematical or a probability method. Let us see an example. This is a 2 into 2 matrix, 3, 5, 4, 1, and here we apply the maximin minimax rule as we discussed in the pure strategy situation. There is no saddle point, so it is, of course, it is a mixed strategy problem. Here maximin is 3 and minimax is 4. So it is a mixed strategy problem. So let us see the mathematical or probability method to solve the problem. Step 1. There is a different method for solving the mathematical method. I am taking only one method in this example. There will be some other methods also there. So this is one method. You take the highest value minus lowest value, and take the difference between the highest value and lowest value in the matrix. See 5, 3 and 5, difference is 2, 4 and 1, difference is 3. Then the second one is also like this, 3 and 4, difference is 1, 5 and 1, difference is 4. Then the step 2, this is the step 2, change the position of values calculated at step 1. You have calculated the values at step 1, you just change the position. You have to put 3 on top and 2 on the position of 3. In the same way, you can interchange 1 to 4 and 4 to 1. Just change the values. That is 4 first and 1 in the second one. So this is step 2. And the step 3 is division by total. That is the next step. So you divide the total values. That is 3 plus 2 is equal to 5, 3 by 5 and 2 by 5. That is called a division by total. That is the next step. Here 4 plus 1 is equal to 5, that is 4 by 5 and 1 by 5. So this is the way you have to divide that value with the total value. That is the next process. Then the next one is the step 4. You have to find out the calculated values in a table. There will be a 3-column table, and the first column is the payoff. Second column is the probability, and value of the column is the third column. So value of the game is equal to the payoff into probability. So 3 columns are there. First column is the payoff column, second column is the probability column, and the third column is the value of the game column. You have to enter your payoff values in the payoff column. then find out the respective probabilities. For example, 3 is the payoff value. 3, you look at the previous matrix, you can see 3 by 5 and 2 by 5 are the probability values. Then you multiply the 3 by 5 into 4 by 5, 3 by 5 into 4 by 5, that is 12 by 25. Then you multiply that value with the payoff, that is 3 into 12 by 25 is equal to 36 by 25. Let us take the second one. In case of 5, payoff is 3 by 5 and 1 by 5. You multiply 3 by 5 into 1 by 5, that is 3 by 25. Then you multiply that value into 5, that is 5 into 3 by 25, that is equal to 15 by 25. Then you take the value 4, that the probability is 2 by 5 and 4 by 5. The total is 8 by 25. 4 into 8 by 25 is equal to 3 by 32 by 25. 32 by 25. So you take the last value 1, the probability is 1 by 5 into 2 by 5, that is equal to 2 by 25. 1 into 2 by 25 is equal to 2 by 25. So this is the way how to find out the value of the game part payoff into probabilities, and you have to find out the final expected value of the game by finding out the total of all that values together. So here it is 85 by 25, that is 36 plus 15 by plus 32 plus 2 divided by 25, that is equal to 17 by 2. So this is the value of a mixed strategy game. Let us move to the next method, that is called a graphical method. So how to solve a game problem by using graphical method? So if you want to solve a game problem into graphical method, these are two conditions. A game will be a 2 into n game. There will be 2 rows and n columns. 2 rows and n columns, and m rows and 2 columns. So there will be, first case there will be 2 rows, second case there will be 2 columns. 2 into n game and m into 2 game. So these are the two ways we can calculate, we can use graphical method to solve a game problem. Let us see how to use. This is the example of a 2 into n game. These are the 2 rows, A1, A2 are the rows, B1, B2, B3 and B4 are the columns. Let us see how to calculate the values. This is a 2 into n matrix where n is equal to 4, and you can make it into 2 into 2 forms. The size can be, you are using the graphical method to reduce the matrix into 2 into 2. Let us see, these are the procedures that we can do. First, we have to draw 2 parallel lines, that is called A2 and A1. So you give the first variable, A2 is the first variable and A1 is the second variable, and you identify each value of B1, B2, B3 and B4. Then you plot the value by connecting a line between A2 and A1. Drawing the line connecting A2 and A1, then you can plot the values of B1, B2, B3, B4. Then since this is a 2 into n game, your shading area of a particular game problem in the graph paper is the bottom portion. So you shade that bottom portion of the graph. So then you give the values, assign the values like L, M, N, O, P. You can give whatever the name you like. You can give that, assign the values. Then you identify the maximum point or the highest point in that shaded area. So here you can see that the highest point or the maximum point in that shaded area is N. So it is the intersection of 2 lines. You just go through the graph, it is the intersection of 2 lines, that is B1 and B4. It is the intersection of 2 lines, B1 and B4. Then you take this B1 and 4 values and and create a new matrix. So let us see, there will be a 2 into 2 matrix based on taking the values of B1 and B4. So this is the new matrix. So now we can use this problem by solving that one by using mathematical method. Now we can solve the problem by using the mathematical method. And finally, I have already discussed the steps of computing mathematical method: highest value minus lowest value, position changer, division by total, payoff, probability, value of the game. So that is why you can solve this particular matrix into mathematical method, and finally you will get a value of the game like this. So here the problem to convert your that particular matrix into 2 into 2 matrix, you are using this particular graphical method. So after converting it into this particular that is 2 into 2 matrix, you can use the normal mathematical or probability method to solve the problem. So this is the way you can solve the first type of a graphical method of game problem. Let us move to the second type of a game problem. This is M into 2 game problem. Here there will be 2 columns and 5 rows. Here the M is equal to 5 and 5 rows and 2 columns are there. So you can use the graphical method to solve this particular game problem. Let us see what are the things going to happen in this particular situation. We are drawing 2 parallel lines as we discussed in the first case, and the first one is called B2 and the second one is called B1. And you have to identify this, what are the things that you have to interconnect, that is different situations of A1, A2, A3, A4 and A5. You identify the points and draw a straight line while connecting this different values in that particular graph paper. So once you have to draw lines between B2 and B1 for A1, A2, A3, A4 and A5 values, so you have to shade at the upper position in the graph paper, since it is a 2 into n game. This is a 2 into n game, so you have to shade at the upper position of your graph paper. Then once you shade at the upper position, let us see you can see in the video, upper portion has been shaded, and you have to give the that intersection point values, that is L, M, N, O, that is the intersection point values. Then you have to find out the lowest point in that shaded area. That is the lowest point in that shaded area. So see, the lowest point is N. Lowest point is N, and what are you have to identify what are the lines that is connecting in that particular lowest that is point, that is A4 and A5. A4 and A5 is connecting at the lowest point. So you take that particular 2 points and draw a 2 matrix, that is A4 and A5. Then this is the new matrix 2, 5, 7, minus 6. Now it is a 2 into 2 matrix. Then you can apply the method of mathematical or probability method to solve this particular problem, as we discussed in this previous method. Then once you solve the problem, you will get the value of the game as 23 by 20. So this is the second category of a game problem. Let us move to the next topic: formulation of LPP by formulation of a game problem from the LPP. So let us see, this is a player 1, player 2 matrix. How to formulate linear programming problem from a game theory matrix. So LPP equation, how to formulate that one, that we are going to discuss. See, here 2 players are in this game, player A and player B. One player maximizes result, means second player reduces loss. You have to point the LPP. One here we have two situations. One LPP is the maximization problem, and another one is the minimization problem. You have to formulate two LPP from the part of two players, and one LPP is the maximization problem, and another one is the minimization problem. Let us see. These are the two LPPs. See. Here in respect of player A, the objective function is let us say x1 plus 6x2 plus 5x3. That is in case of player B. It's player A strategy. Then second one, 7x1 plus 2x2 plus x3. That is a greater than or equal to 1. That is a second one. Then third one, 2x1 plus 7x2 plus 6x3 greater than or equal to 1. That is the third equation. And that is in case of in respect of player A. And negativity is always x1 comma x2 greater than or equal to 0. When you take the in respect of the second player, that is B. So you take the values as y. So first one have to minimize. Objective function is minimization, and second one is the objective function is the maximization. So y1 plus y2 plus y3 max z is equal to y1 plus y2 plus y3. Then the subject to y1 plus 7y2 plus 2y3 less than or equal to 1, 6y1 plus 2y2 plus 7y3 less than or equal to 1, 5y1 plus y2 plus 6y3 less than or equal to 1. These are the values, and non-negativity is y1 y2 greater than or equal to 0. So this is the way you can formulate LPP for a game problem. So minimization of LPP based on the game problem, and here it is a maximization LPP based on the game problem. You have to can formulate two game problems, and you can apply simplex method to solve this particular one. Normally, what are the steps that we are following in the simplex method? You can solve this particular problem. So the main points that you have to remember: how you have a particular game problem, so apply maximum minimax rule. Try to identify the saddle point, and the value of the saddle point is the value of the game if it is a pure strategy game. So whatever the game that you are getting, you have to apply maximum minimax principle. If you are getting saddle point, that will be the value of the game. So of course that will be a pure strategy game. So if there is no saddle point, of course you can go for the further process. It is a mixed strategy game. So you can go for another option. You can use the principle of dominance to reduce the size of the matrix. So reduce the size of the matrix, you can apply the principle of dominance. If the matrix is 2 into 2 with no saddle point, if the matrix is 2 into 2 and there is no saddle point, you can apply the mathematical or probability method to solve the game. That is highest value minus lowest value, position change, division by total. Then you have to prepare the table payoff probability and the value of the game. Then you have to find out the final value of your game situation. Then another one, if it is a 2 into n or m into 2 game, you are applying the graphic method. Then you have to identify the 2 into 2 matrix. Then you apply the mathematical method to solve the problem. Then if it is an m into n game, you can apply linear programming problem method to solve that particular game situation. And what is a 2-person zero-sum game? A game consists of 2 persons and the value of a game is exactly equal to 0. There will be only 2 persons and the value is exactly equal to 0. Then it is called a 2-person zero-sum game. So it is otherwise called a rectangular game. These are the important points that you have to remember in the game theory chapter. So thank you for watching, and